Alright, so number 11 is talking about the scale on a map. 1 inch on the map is 20 miles in reality, in actual distance. So 1 inch is 20 miles. Okay, so it's a ratio of 1 to 20. The actual distance between Disneyland and Legoland is 96 miles. What is the distance on the map? So 1 over 20, we want to know what is the distance on the map. So the map number is the 1. You know, the 1 on the top, the numerator. So I'm going to put X right here. And then the 20 represents the miles, right? The actual distance. So I'm going to put 96 right here. So we've set up a proportion that we solve by cross multiplying. So 20 times X equals 1 times 96. So 20x equals 96. We divide by 20 on both sides. And then when you divide 96 by 20, you get 4.8. So on the map, it's going to be 4.8 inches. Okay. Number 12, Mike is riding his bike at 15 miles per hour. What is his speed in feet per second? Use 5,280 feet for 1 mile. Okay, so this is where we're going to go, let me draw the, I'm going to need a long one like this. Hope it fits. So we start off with 15 miles per hour. And that's 1 hour. Okay. I should probably use black instead. And we want to convert it. We want to end up with feet per second. So let's go ahead and change the hours to seconds. So let's do one thing at a time. So 1 hour. So if I wanted to cancel, I put the 1 hour in the numerator. 1 hour is 60 minutes. Okay, so what happens here? Hour and hour cancel. I also know that 1 minute is 60 seconds. Okay, and close that one up. And minute cancels. Okay, so right now I have miles per second. Well, I know that 1 mile, they told you that right here, right? 1 mile is 5,280 feet. Since I have mile in the top in the numerator, I'm going to put 1 mile right here in the bottom. Is 5,280 feet. So mile cancels with mile. So notice what we have left. We have feet in the numerator and seconds in the bottom. So now we're ready to multiply and divide, right? So we're going to multiply across, and in the denominator, so let me just close this up. Erase the extra. So in the denominator, I have 3,600 seconds. And in the numerator, I have 15 times 5,280. That's going to be 79,200 feet. So when you divide, you get 22 feet per second. Okay. Letter B, if John is writing at 25 feet per second, who's writing faster? Explain how you know. Well, John is 25 feet per second. That's his unit rate, right? 25 feet for every 1 second, whereas Mike is only covering 22 feet in 1 second. So who's writing faster? John, because he's covering more feet per second than Mike is. Alright, so for number 13, excuse me, a 6-foot building casts a shadow that is 15 feet long. So here's a 6-foot building, and here's a shadow 15 feet long. So we'll do it this way, 15 feet. I'll put it right here. At the same time, a building casts a shadow that is 45 feet long. So we don't know the height of the building, but we know that it's casting a shadow that is 45 feet long. So I'm going to set up a proportion. I'm going to compare the building to the shadow. Like I'm going to do a ratio of the building to the shadow, to its shadow. So it's going to be, for the first one, 6 over 15. It's going to equal x over 45. Because the sun is hitting the buildings at the same time. So the shadows are proportional. Okay, and so you have this, so we're going to multiply. So 6 times 45 equals 15 times x. So then 6 times 45, put that into your calculator. That's 270 equals 15x. So we're solving for x, right? The height of the building. So you do over 15. And so you have divided by 15. The building is 18 feet high. That's the height of the building. You could have also done a proportion comparing building to building, shadow to shadow, like this. 6 over x, that's building to building, equals, but you have to make sure that you do the shadows in the same order. So the shorter shadow over the longer shadow, just like I did the building. And notice when you multiply, you get the same exact equation. 15x equals 270. So you could set it up 2 different ways, but then your answer is going to be the same. Okay, number 14. It says, Lori is selling a Girl Scout cookies for her troop. Her goal is to sell 500 boxes. So far she has sold 180 boxes. Write an equation to model the situation. How many more boxes does Lori have to sell? Well, if we're asking how many she has to sell, she could start setting it up by some number of boxes, x, plus 180, which are the ones she sold. The total has to be 500. Okay? And then to solve for x, you subtract 180 on both sides. So x is, this is 0, and that's going to be 320 boxes. She still needs to sell. Alright, so let's say that here you have, there's something missing on the dimensions here of the labeled dimensions on the rectangle. It tells you that the perimeter is 56 feet long. The width is 2 feet less than the length. Okay, so we'll say this is the width right here, and let's say this. So this is the width. And this would be the length. Call this the length. Call this the width. So the width is 2 feet less. So this is going to be W minus 2. Okay, so the width is 2 feet. Or well, actually, you know what we could do? We can just make this W and make this W plus 2 because it's longer. Because the width is 2 feet less. Then that way when we find the answer for W, we're done. Because we're looking for that. Now you know that in a rectangle, opposite sides are equal. So this is W and this is W plus 2. So the perimeter, the distance around, is 56 feet. And so if you go all the way around, you have 4 W's, right? You add up all the W's, plus the 2 here and the 2 here, that's going to be 4. So I'm going to subtract, 56. I'm going to subtract 4 from both sides, and I get 4W is 52. Then I'm going to divide by 4 to leave W by itself. 52 divided by 4 is going to be 13. So the width is 13 feet long. Okay. Number 16, Tina's saving to buy a notebook computer. She has 2 options. The first is to put $200 away initially and save $10 every month. The second is to put $100 away initially and save $30 every month. After how many months would Tina save the same amount of money, or the same amounts using either option? So here the key is the same amounts, right? So let's move this up a little bit. In the first one, I'll do different colors. In the first one, she puts away $200 initially and then $10 every month. So that's going to be in blue. So that's 200 plus $10 every month. We'll use, it doesn't give you a variable, so we'll use M. M would be the number of months. Okay. In the second one, she puts away $100 and saves $30 every month, right? So that's going to be $100 initially plus 30M, $30 every month. So after how many months would Tina save the same amount using either option? So when would these be the same? When would these be the same? So we set the equation, set up an equation, 200 plus 10M equals 100 plus 30M. So I'm going to subtract 10M from both sides. So that's 0. 200 equals 100 plus 20M. I'm going to subtract 100. Again, my goal is to solve for M. Minus 100. So that's going to be 100 on the left side. This is 0, 20M. So I'm going to divide by 20. So M is 5. So it would take 5 months for them to save the same amount of money. And then it says how much would she save with either option, right? Because it's the same amount of money. So in 5 months, 200 plus 10 times 5, that's 50 right here, so that's $250. And again, just to verify, the other option, 5 right here, that's 100, and this is 150, so that's going to be $250. So she would have saved $250 with either option.